Here we are at the most western point of Reed College Canyon along 28th Street. It's an old century farm that Reed College purchased in 2007 with hopes of extending the restoration efforts along the Crystal Springs Creek corridor. One of the major components of the farm restoration was the remeandering and restructuring of the stream channel. As we looked towards the stream initially before the restoration, there was a great deal of energy put into straightening the stream out and cementing the edges of the creek with railroad ties and chunks of concrete. This sort of straightening was probably done in the early years to minimize inundation with groundwater to open up the area for more farming potential. What we know now is that straightening of the stream corridor actually increases flooding downstream and makes it unpassable for migratory species to move up into Reed College Canyon. The straightened section of stream flowed westernly towards 28th Street through an undersized culvert system. The need for a wider culvert system that doesn't impact water flow was one of the most needed features of the site. After 3 years of planning and forming partnerships, this area was ready to move forward with the restoration in the summer of 2010. The restoration process began in July, which is the beginning of the in-stream session where you can enter a stream channel with the hopes of not disturbing nesting or spawning fish. One of the most difficult aspects of doing stream restoration is actually what to do with the stream during the construction process. We put the stream into a pipe so that we can move the water around the work zone during the construction period. Plastic sheeting creates what we call a cofferdam. And cofferdams enable us to build the water table and get the proper elevation so that we can move the stream through the pipe at a different elevation than it's normally used to flowing. Reed Canyon is fortunate to be centered around a spring-fed aquifer system. But one of the things that makes this difficult when assessing this stream for fish habitat is that the constant flow of spring water over time creates a very uniformly flat-bottom stream bed. In the process of restoring this section of Crystal Springs, we introduced large woody debris. These logs act as pinch points to the stream, changing the velocity, ensuring that the pools that we created will be scoured and kept free from debris, in turn providing better habitat and refuge for large fish to rest in. On the south side of the farm property, we introduced a green street or bioswale system. The function of this vegetated swale is to collect all the surface water from 28th Street, clean it as it passes through the plant material, pulling away the oils and the heavy metals, and allowing that water to infiltrate into the ground, rejoining with the spring water source. Centered in the middle of the new restoration project, we see a large raptor pole. This raptor pole has two functions. Its initial and most obvious function is to provide habitat for nesting birds of prey. Its secondary function acts as a capillary towards a lower spring system. This log has been buried 6 feet in the ground, which then allows spring water to percolate up at its base to form a backwater pool. This backwater pool is very important for amphibians for breeding and refuge in this slow-moving water system. This project is a culmination and partnership between Reed College and the Bureau of Environmental Services, the Jupitz Foundation, the Bullitt Foundation, the National Fish and Wildlife Foundation, the Oregon Department of Fish and Wildlife, the Oregon Watershed Enhancement Board, and the City of Portland. Crystal Springs is a valuable asset to the City of Portland as it is the cleanest, coldest water source left in the City of Portland, which free flows from its source here on Reed College campus all the way to the Pacific Ocean. With a series of these projects and the proposed project by the City of Portland downstream, this system will continue to increase in value and potential for migratory species to continue to come upstream and find these cold water sources.